Hi guys, this is Mr. Gagnon again, and we're going to talk about like one of the last topics of the school year here, and that is the energy of a spring. I'm going to give you a couple problems to work with, and also I'm going to give you a pretty detailed explanation on this. So in class, I'm probably going to talk to you guys about some like real life situations where you have springs. One of them would be a car. Another one would be, like a watch, or even the spring in your shoe. You can calculate the spring constant of that and use that to figure out the energy of a spring. So, let me first of all we'll get it down where we're looking at the energy of a spring. We're gonna call it energy sub S, or energy of a spring. Um, Now, first of all, I'm going to give you the formula for this. That way, we can kind of get right on with the calculations. Okay, so the energy is something that we can measure based on a few characteristics of the spring. Okay, this may look familiar to you. Okay, it can be multiplied by 1/2 k x squared. Okay, now we have a formula that gives us the energy, the kinetic energy, as 1/2 mv squared. So this is along the same lines, but with a couple different constants. So K, we know, is our spring constant. Okay, which tells us how strong the spring is. And X in this formula is stretch or compression. Okay, and what I'm going to do is I'm going to show you what stretch or compression is with a picture. So stretch, let's say the spring started out looking like this. Okay, and then it stretched to look like this. So if you look at it, the distance that it stretched, or the x value, is here. Okay, that's how much it stretched by. Okay, and compression is the complete opposite of that, where if you have a spring that starts out that's longer, like this one, and then you crush it up or compress it, and it ends up looking like this. Okay, then the distance that you crushed it or compressed it is x as well. Okay, and let's not stress the negative and positives here. Okay, negative and positive is just a direction, and we can identify that later on. Okay, so there's stretching and there's compressing, and the difference is that this takes a force to compress it. So the spring sits like this normally. That's how it sits. This spring sits like this normally, and it takes a force to stretch it out. Spring like this one, a compression spring, could be something that you would find in your car or truck, where the mass of the truck is pushing down with gravity and causing the spring to compress. This type of situation is kind of like a bungee cord. How much will the bungee cord stretch out? Okay, so there's the formula, there's the definition of stretch and compression, and here are your variables. Okay, 1/2 kx squared. So let's look at an example of that. And we're going to have to do examples that give us k and x. We're going to have to do examples that give us the energy and ask us how much it should stretch by. We're also going to have examples where we're going to have to find the spring constant. So let's take a peek at it. Okay, example 1. Okay, I'm going to ask for the energy of a spring, and I'm going to give you the two values. I'm going to give you the K value, how strong the spring is, of 10 newtons per meter. I'm also going to give you a stretch distance of 2 meters. Okay, so this is how you're finding for the energy of a spring. Okay, now order of operations. Okay, I can solve and I can get 2 squared. So let's go ahead and find what this energy is. Energy of a spring, half times 10 times 2 squared, which is 4. Okay, 10 times 4, 40. Half of 40 is 20. Okay, so we just solved it for that, for the formula, and the units here for energy are joules. So the energy of by the spring here is 20 joules. Okay, and that's the basic simple version of that. Okay, we're going to do one more video showing how to solve for X and also how to solve for a spring constant.